So first thing we are going to see is what is memory. Like there are mainly two kinds of memory. One is secondary memory, and next one is primary memory. Secondary memory refers to ROM. Okay, so we will be having ROM inside our this is called read-only memory, and like inside our computer, like we will be having hard disk. So secondary memory means hard disk, and that will be like 1 TB, something like we are having. And coming to the primary memory, it is like a RAM. Okay, RAM means random access memory, and we generally we will be having 8 GB. Okay, secondary memory is slow memory, like it is slow compared to primary memory. Primary memory is very fast, and we can relate like an analogy, like in the secondary memory you will be having all the programs irrespective of whatever the programs you install in your system. Like you can install as many programs into your system, all of them will be, those programs will be stored in the program files. So all those files will be stored in the hard disk. But whenever you want to execute a program, you will get that program, you will pick that program from the hard disk and keep it in the RAM. Something like whenever we want to cook some dish, all the vegetables will be stored in the fridge. You want to cook some particular dish, you will just pick the vegetable and cut it into pieces like bites and put it into a vessel, and with the help of stove you will cook it. So similarly, what we do is we will take the program from the hard disk, put it in the primary memory, and then cook it using the stove. So this is the analogy. So just remember, you might be getting understanding of what is secondary memory, primary memory, and processor. Next step, going to see. So we saw like there will be a primary memory, right? So primary memory, the main usage is it is the actual execution of programs. Like we do actual execution of programs in primary memory. Something like we do actual cooking in primary memory. So coming to primary memory, we can divide it into like it is already like we divided it into two parts. Primary memory is divided into two parts. One is called stack and another is called heap. Stack means, like generally what we get, remember, stack means which are piled up. Like piled up things are called stack. Like you can see these are piled up. Whereas heap means those are like a random set of things which are there. So we can also refer the stack and heap. Coming to the memory, it looks like this. You can take analogy to a book. So a book will be containing index pages or content pages. So I mean to say index pages. So these index pages are stack, and heap is content pages, the actual chapters. So whatever the actual chapters we are having, so those are called heap. So there will be a reference from stack to heap, right? So in your book you can see there will be numbers which are referring to the page numbers of the real chapters. So stack is something like a which will be like a index pages, whereas heap is like a big memory where you can having the real content. So in a computer system there will be a stack. So stack is of like a small size compared to heap. Heap will be a big size memory. Okay, and stack is fast because it is ordered, whereas heap is not so fast. Okay, so we use stack and heap for different purposes in the computer, like for programming. So let us see those things. Okay, so going forward, so you can see actually what we do is in stack we create some variables, and in heap we create objects. So we say here we create variables and we create objects, and stack will refer to the objects. A pointer will be referring to the objects in the heap. So here you see this is a object, and it will be having an address. So this address gets stored in the stack. So we store object address in the stack. There can also be a pointer in the object also, like you can have a like internal pointers also in the heap. So this is the a diagram to show how a stack will be having and how a heap looks. Okay, inside the memory, this is the diagram. So yeah, next going forward, so this is how it looks actually in the coding. So when you create a string or a string array, so what it does, it creates a string array, and in that string array, like a something like this, and it will store those values. So some employee object, see here it will be creating an employee object, and employee will be having like all these, and again name is a string, that is a character, like a collection of characters. So collection of characters will be stored somewhere. So all this chaining will be there inside the memory. So two objects also can refer to like two references. These are called references. E1 and E2 are called references. So sorry, E2, E3, all these are called references. E1, E2, E3. So two references can also refer to one object. So the object looks like this, and here you see name is a string. String means collection of characters. So characters again pointing to another memory location. So there will be a chaining of memory locations inside the heap and stack. So this is just to show how they look inside. Okay. So going forward, what is to classify what is stack and heap? So for a stack, the access speed is very fast. Coming to heap, the access speed is slow. And memory management, like CPU will be having a automatic memory management for stack. Like you create something in the stack, and like the CPU will be deleting those things when it is not used directly, because it knows it's not a random thing, like there will be ordered, these are all ordered, so it knows, and it does all those things. Whereas coming to the heap, there is no deallocation or freeing of memory directly in the heap. Generally you have to do. But Java and .NET are provided with a default garbage collectors which does the work for you. So what a garbage collector will do is, see there is a pointer from here to here, right? Then this pointer gets lost. Then this memory will be treated as a free memory, like a memory without having a reference inside the stack. So that will be deleted. So any memory, see here there is no reference for this object inside the stack. So this will be by the garbage collector. So garbage collector sees in the heap the objects which are not having the references in the stack. If it finds any object without any reference, without any address stored in the stack, the garbage collector treats, okay, nobody is using this object because it doesn't have any reference in the stack, so this can, so it will automatically free that object. So that is the duty of the garbage collector. That is the program provided by Java and .NET. They automatically provide. Whereas coming to the C and C++, there is no garbage collector inside those languages. You have to manually do it. So there are some functions to do them, like we write destructors, and we will be having malloc functions to do the garbage collection or freeing of memory. Why we need to free the memory? Because there will be a overflow will occur, like your memory will get filled with all the objects and there is no space to create new objects. So that your memory will be overflowed and you will be out of memory and you cannot run your programs. So that is why sometimes we can see like if you install like less memory, your programs will be like slow. You cannot create many programs, first thing, and there can be a stack overflow also. Like there are many stack variables stored and no place in the stack, then stack overflow occurs, and heap overflow also can occur. But generally we use the overflow word for the stack, because stack is something like which can be get filled, whereas heap is like a very large one. So that is the difference between coming to the memory management. CPU does the stack, it manages the stack. Like efficient usage, like you can see, yes, stack is effectively used. It knows where there is empty, like if there is an emptiness, it can directly create a variable in the stack. Whereas because it is automatically managed. Whereas coming to the heap, though garbage collector does all the heap thing, there will be some spaces here and there. We don't like when we create an object, so it looks for a space wherever it is available, it creates the object over there. So it is not like a ordered thing. So variable scope is local and variable scope is global. So this we will discuss. And size is limited, like OS dependent. Generally there is no limit rather than the limit of the physical memory. Yes. So variable resizing, this we don't no need to discuss here, but yeah, this is about like when you create a, let us think, I will let you know, like when you create a int variable, int gets created using a fixed size, like 4 bytes. 4 bytes is a fixed size of int, so that gets created in the stack. Whereas when you create a string is an object, so it gets created inside the heap. So there is no fixed size for a string. We can store a big string or a small string. So there is no variable sizing, like it can resize itself, something like that. But actually string is not a resizable one. Array can be a resizable, something like that. You can think like object can grow, I mean to say. String is unimmutable. So that is a major difference between, like, an object. Object doesn't have a fixed size. Actually, it can vary. The size can vary. Whereas a stack variables can be of like a fixed size. That is a thing. And pointers. So here we don't. There are no pointers here, but here there will be pointers. You can see there is a pointer for this here. But for stack, remember there is no pointer. So that is a major difference between stack and heap. Just remember, this is like a simple thing what I created to show you, so that you can remember a difference between stack and heap. So yeah. So try connecting using phone. So and okay, so coming to next thing we are going to discuss is about client server or web server architecture. So what is a client and what is a server? Generally we use these terms like client, server. So in specific, server is the one which serves a request. Client is the one who gives a request. Like you do work, you will be having clients. Like for a doctor, patient is a client. Okay, and because doctor serves the patient and patient gets the service. So client is the one who requests the service. Server is the one who provides the service. So generally, like coming to the computer world, like we can see the client means client can be a laptop or a phone or a desktop, and whereas server is a computer. Like everything is like a computer. Like all these are computers, and they communicate over the internet. Like client sends a request through the internet to the server. So how it only reaches the server through the IP address. Through the IP address, it exactly reaches the particular server. Like you send a request to your Google, so it looks at the domain, and there will be a domain registry inside the internet, and in that registry there will be like okay, Google http.google.com. So it finds the IP address of that Google, and it goes to the server, and this is how it works. Coming to like deep into the website architecture, you can see a client can understand only something like it makes a request through HTTP that sends into a web server or server. Server processes it. It uses the database and it queries the database using it sends a query to the SQL, and there will be a result back, and using that result it will fill that web page, and it will send that response back to the client. So what's happening here is what I want to mention here is a client can understand only few things. A client means a browser. here in our sense. A browser can understand only few things. A browser can understand CSS, HTML, JavaScript, and some other scripts and images and XML, those things. But it cannot understand Java. It cannot understand C#. It cannot understand PHP, either of these, or ASP or anything. So all those will be used by only the server. So server uses those engines like .NET engine, PHP engine, or Java engine, and it fills whatever the data that gets from the database onto a web page, and it creates a plain HTML page and sends that response back. So to send to the client, we use only JavaScript, CSS, whereas coming to the and server can understand the why? Because server will be having the engine, so client will not be having the engine. So we generally install the engines only in the server. So that engine can be a C# engine or a Java engine or a PHP engine. Those things. Angular is a JavaScript. So Angular runs on the client. So only like Angular, React, all those are JavaScripts, jQuery. So that is a major thing what is happening in the web server architecture. Coming to like class and object, like a class is a blueprint. You can see here there is a blueprint of a car. Using this blueprint, we can create as many cars as we need. Like we can create n number of cars. So same thing we are doing with the programming classes and programming objects. For a class, we will be creating objects. So class, we create objects. So objects are the real entities. Okay, class is not the real entity. Class is like some file we write, whereas objects get created in the memory. So objects are having the memory, classes will not be having the memory. So here you can see with a blueprint we can create some houses. All these houses, like you can paint them in different colors. See, one blueprint can create several similar but different houses you can create. So that's the thing we create. Okay, that is a class means blueprint, whereas object means instance of a class. So that's the thing. So this is a plain thing. And coming to classes versus object, we can say that classes are the code definition for object. So we define something as a for an object, like how object need to be there, like how object need to look. So we can call them as blueprint, and objects are created when the program runs. So when we run the program, so objects gets created in the heap, main memory in the heap, and the reference will be stored in the stack. So that is the thing. So similar to declaring a variable. So that is the thing. So to create a object, there will be a constructor. To destroy an object, there will be a destructor. So we use a constructor to create an object and destructor to destroy an object. But coming to C# and Java, there is an automatic memory management. So generally we don't write destructors. So as there is a garbage collector which does the work for us, we just use and throw, and it comes there and collects all the unused things. So that was garbage collector does. So garbage collector does is collecting the unused things. So destruction is done by garbage, means essentially destruction is done by garbage collector. So we appointed a separate program to do that work, whereas creation we are going to do it. So we write constructors to create an object. So how they look, coming to here you can see. So let us think we want to create a student object. So here is how it goes. So this is the class name and this is the object name, or we call this as reference. This is a reference. This gets stored in the stack, and we create a object here. This is called new student is an object, and student is a constructor. So constructor is a function. So we are calling a function to create an object. So constructor is a function which creates an object. So constructor will be having the same name. This function is going to have the same name as the class name. So we create an object using the keyword new. So this is a anatomy of the constructor. Okay. So how it looks is student, like for a class, if you want to create an object, class, then object name, then keyword, then constructor, then the keyword, new keyword, then constructor. So this is how
class name.
constructor always will be having the class name, but construction is a function. Constructor is a method or function. Okay, constructor is a method. So that is how we create a constructor. So next, coming to see here, anatomy of a class. This is, we can say. See, what does it mean is, see here we declared a class. Inside the class we will be having a member. That member, generally we call it as state. We call it as state or structure, but we generally say it as state. Okay, it is state, not structure. And the methods here you can see this is a method. So this method is called behavior, state and behavior. So class will be having two things, one is state and another is behavior. So we want to create a class. So how we can create? Car1 is the reference, and we are going to call the constructor. Here you can see there is no constructor defined, but automatically C# creates a constructor for every class. For every class there is a constructor inside. You don't know that it is declared, but you can also declare your own. So you want to override that constructor, you can declare your own. But there is always a default constructor provided for every class by the C#. So you can see there is no car method inside the car method inside the car class, because C# has provided the car method, or Java will provide the car method. So automatically that constructor is provided by default it is provided by the Java C#. So here this is the way how you can create a cars. You can create as many cars you want. Here we have created 2 cars. So, and for first car we have given the odometer reading like 1, and for the second car we want to give the odometer reading 2, and when we move forward the odometer reading gets improved, like increased. So this is how we wrote the method. So this is how the class and the object and how to create a constructor, and what is a member, what is a state, behavior, those things. Okay, so those things. Next, this is the anatomy of a C# program or C#. Okay, so what does that mean here? Okay, see here, when you create a program in C#, it looks like this. Okay, so here we will be having a namespace. So we will see what is a namespace, what is a class, and what are the member variables, constructor, member functions, entry point, those things. Okay, so here the top level things using, you can see using, these are analogy to import statements in Java. So what does it mean? We created some namespaces somewhere and we want to use those namespaces here, so we include those. So namespace means what? Namespace means, we can say namespace like this. Namespace means a logical grouping of structures. Okay, logical grouping of structures. A namespace can contain classes, interfaces, abstract classes, structures, enums, all those things inside a namespace. So we can create like classes, like namespace is a collection of classes, you can think something like that. So, and also a namespace can also contain a namespace inside it. Okay, a namespace can also contain namespace inside. So namespace is a logical organization of a structures, like programming structures. So here you can see this namespace, demo namespace, is having a programming structure called class, called program inside it. So namespace contain classes, something like package contain classes, and these are the member variables of a class. And this is a constructor. You can see the constructor name and the class name are both are same. And here you can see we are supplying some input arguments to that constructor, so that we can assign n to name and a to age. So we want to assign these two to these two. So we can send them as parameters, and these are called member functions to set some data and show some data. And here you can see this is the main entry point. Like here, from here the program execution starts. So any program, like we create an exe file, every exe file should have a main entry point in order to get executed. So exe file will be having a main class, whereas DLL files we will be having, those will not be having a main class. Those are something like straightforward libraries. Okay, so we will discuss all those two things. Okay, so this is how the anatomy of a class looks, okay, or a program looks. So namespace can contain classes and namespace can contain namespace. So namespace, and you want to reference the C1, you can reference something like that. Inside a class you can also have a class, so you want to reference that one, again dot C2. You can see you want to reference this one, second namespace n1.n2, and third namespace n1.n2.c2. like that it goes. Actually it should be like, you can have like you can see here we have named it as C2 and here also C2. So but there will be, yeah, but as the namespace is different, there is no problem. Inside the same namespace you cannot have two classes with the same name, but in the different namespaces you can have the same name. So that is a logic here. Okay, so that is we will discuss here what is DLL and what is EXE. So DLL stands for Dynamic Link Library, okay, and EXE stands for Executable File. Executable file uses DLLs. So DLL means library. It is a library of functions, collection of functions, collection of classes, collection of namespaces. Library is going to contain namespaces, classes inside that. So you can see this is called assembly or DLL, Dynamic Link Library. Inside a DLL we will be having these information. Like when you go into a MS Corp library, Microsoft Corp library DLL, then you will be having these things. Manifest means like you will be having the information about this DLL, like what is the version of it and who is the copyright owner of this DLL, and when it got last updated, those information. So something about the DLL, you will be having that meta information. And like you can see inside the DLL there are namespaces. There are two namespaces here. One is Microsoft.win32. This is one namespace, and system is another namespace. So there are two namespaces. Inside the system namespace there is another system namespace. Inside that namespace you can see all these namespaces are having a symbol. So this is the symbol says it is a namespace. Once package. Inside the namespace you can see these are classes. So classes looks like this. So these are the different classes inside the system collections. So collections class is having like these collections. Okay, and you can also have a different thing called I. You can see I stands for interface. So there are some interfaces also inside that. And here this is, I think this is for abstract, I think, but I'm not sure. So this is how the DLL looks. So DLL will be having this information. So DLL is a library. Inside the library there are namespaces. Inside the namespaces there can be another namespace. Inside the namespaces again you can have classes and classes, interfaces, abstract classes, those things. So this is how it looks. And exe file, what is the difference between the exe file and a library? Libraries are something like a collection of classes. It cannot execute, but you can execute a exe. So exe will also be having all these things, but the only thing is exe will be having a main method. It can start and get executed by the operating system. Operating system can use that to execute it. So we can use a exe to execute, and exe file can use another library, and a library can use another library. So library can use library. Exe file is a library, and DLL is a library. or we can say both are assembly files. Assembly file is of two types. One is exe, one is library. So we just seeing library like DLL. Assembly is of two types, DLL and exe. So exe is having a main method, DLL is not having a main method. That's it. So this is about a namespace, classes, interfaces, DLL, exe. And coming to next thing, library, DLL, exe, DLL. You can write DLL. Okay. So next we want to see an anatomy of a method. We just mentioned method and different names inside the method, right? So how a method looks and what it actually contains, and those things when we say these are something like key points one should be knowing when somebody says something. See, a method is something like we write like this. This is how a method looks. This is one of the method. So this method, the top level, the line is called signature of a method. And here you can see public is like access specifier. We call it as access specifier, where this method is allowed to use. Access specifier means where this method is accessible or allowed to use, where this is visible, where we can access it. Okay, that is what access specifier is about. And static is also a kind of thing, but it says about whether this is an instance method or static method, or we will discuss about instance and static in the next class. For now, just don't worry about this one, and see at these things. Double is the return type. There are types, actually types inside the like C# or Java. So what are types? Like we will be having like to have a data stored inside a variable. We will be having some specification of types. Something like we will say 1, 2, 3. These are called numbers. Something like Anil, Shravan, Sai. All these are called names, right? So why we are using names? We know that those are names, or those are of different type. Similarly, to represent a data, like any programming language will give some types. Okay, so those types are given to hold the data. Why we have given the types? Because inside the types, like every type will be having a different size to hold different sizes data. So that is what type is about. Okay. So here double is the return type, means this method is going to return something. See here it is returning sum. So sum should be of type double. So sum should be of type double. If sum is of different type, let us think it is of integer type, then this is going to throw an error. So always the return type should be same, matching. Okay, so return type should match the return type here. So return statement should match the return type, you can say. And this is called the method name. Like what is the name of the method? So using this name only we will refer this method. And this is called the argument type, and this is the actual argument variable which is going to hold the data. So this is again you can see here integer type. So here we define one more local variable. Whatever the variables we define or we declare inside these two parentheses are called local variables. Like you create a new variable here, it will be called a local variable. You create it outside, it is not a local variable. So local variable is local only to this method. The lifespan or the scope of this local variable is from this starting point to this ending point. So like wherever you declare, here it gets created, it will be stored in a stack, and after the method call is over, like this here, from here this point, it will be removed from that stack. There will be no memory for this. It will be released, I mean to say. So local variables span or lifespan is within this method. You cannot access the local variable outside this method. It will be living only inside this method. so it is called local variable. And here you can see there is a for loop. We will discuss about loops, and this total thing is called method body, and here there is a return statement. This returns the sum. So it took some numbers and iterated and it calculated the sum and returned the sum. So this is the anatomy of a method. So what we have discussed today is some basic things we have discussed. So we discussed what is about memory, types of memory, what is analogy to memory, and what is stack and heap, and we cannot have a namespace inside a class. So namespace inside a class is not possible. Only classes inside namespace or namespace inside a namespace. And we studied what is the difference between stack and heap. So I just provided all the pictures so that you can remember more. So I always used to learn through pictures. So pictures say us give us more information. Why they named that as heap? Why they named that as stack? Because those are like that inside. So those are like this. You can see pretty much equivalent, and this is the difference. And we just studied what is client server architecture. So there is a thing, and class and object. So that is a thing. And constructor, destructor. First, the destruction is provided by garbage collector, and this is how we create an object. Here you can see a simple program to create different like objects for the class, and anatomy of a C# class, and namespaces and names, class names. You can see you can have same class name in different namespaces, and this is how the MS Corp looks like, and this is how the method definition is. So that is about today's class, and I just want to save this, and you can see inside operating system. I am going into Windows, and I want to go into System 32. Yes, System 32. So I want to go here, and you can see here all these are the DLLs written by Microsoft for this operating system. So these are the DLLs written, and here you can see these are the exe files. So this exe file will be using this DDO proxy and DDO res DLLs. So like that the files will be written. Okay, so here you can see there are different DLLs. So you can see all these are DLLs. So each has its own purpose. So that's the thing. See, notepad, there is a exe file. So this can be executed, whereas this doesn't get executed. Okay, and when you these are NLS files. I mean to say this doesn't get executed. Whereas you can see here, this says application extension. This is the actual application. Okay, so actual application and application extension. Why they have named that like that? Why? Because this application will be using its extension. So exe will be will be using the DLL. So they have named like that. And when you go into the properties, details, you can see the file name, and this is called the meta information. What we are discussing this is the meta information, and this is created this is modified on this is the thing, and this is the version of this exe file, and they modified it in 2017 9th month, and file name is this language, and this is for this product. So you can also create these things, and you can also name these when you are creating. Same information will be available for a DLL. So you go here, properties, details, you can see same information is almost available for a DLL. So like this we create a DL like the files and those details. You want to see a DLL information. You want to see what is inside a DLL. What are the namespaces inside a DLL? You want to check those. You can also check those. Okay. ID LASM. Just ILASM, I think. Let's see. Just a minute. Inspect ADL. So how to inspect a DLL? Okay. So in order to inspect a DLL, you can use ID LASM exe, or you can use a dependency walker. Is a nice free tool. DLL export viewer, reflector. There are many tools. Generally, I will be using ID LASM exe. So object browser, object explorer or browser. What is that? Object browser. Object browser. There's no browser. Just a minute. IL, yeah, IL dash. Just don't remember. ID disassembler, IL, intermediate language disassembler. So how you can do is, you can go here. There are many things you can see. So it is not there. Just download it. You can also download it. Generally, it will be installed inside our IL dash. So let's download that now. So where it is, download. How to download it? This tool is automatically installed in Visual Studio. To run this tool, use the developer command prompt or Visual Studio command prompt. Okay, you need to use the command prompt, but not a we should use Visual Studio command prompt. So just give a minute. Somebody messaged me. Yeah, thank you. Visual Studio command prompt. Or I can go here. So I'm going to Visual Studio and developer command prompt, or I can use either of them. So okay. So now ildsm.exe, then I need to provide this copy and provide that one. So has no CLR header. Disassembled. Okay. So let us do for some other thing. Let us do for this. I think I need to give some. I don't know whether this can be disassembled or not, but I will give my own assembly and let us see that one. Okay. So what I created. I'm going into C and I'm going into my drive projects, and I have a movie app, content, application. So this is not a room. Let us take this one in. Let us take DLL. So this one. So properties. I'm going to security. What's this? You can see it. So Ekarun, I wrote this is a namespace, and I have a controller namespace. Inside that there are classes. So these are the classes. So yeah, and this is a manifest. So manifest assembly version, those things. Manifest information this is about. And so this is using all these external libraries. So it says what it is going to use inside that. Okay. And I will open that solution so that you will be having an understanding of what exactly that is. So Visual Studio, I'm opening that one. So just yeah, so that solution I'm opening. So here you can see this is under the namespace tekarun.controllers. So tekarun is the namespace. Inside that there is a tekarun controllers, and that's what we are looking at here. So tekarun controllers, and tekarun global is another namespace. So global.acx, you go inside that tekarun global, I think. Where is it? Okay. So tekarun.global, not sure, but it will be there somewhere. inside that, and here you can see Karun root config. So those are not namespaces actually. Those are not namespaces. Those are classes directly defined inside the Tekarun namespace. So these are the classes defined directly inside the top namespace, and inside this namespace there is another namespace that is called Tekarun controllers, and this namespace has these 4 classes. And you go into that, you can see there are 4 methods in fact. One is a constructor, and this is a about us method, index method, technologies method. So these are the methods I have inside them, and these 2 are what it is extending, like it extends the MVC controller. So you go inside that controllers namespace, see it is extending another controller. So that is what this is showing us. So it is extending. So this is how the information inside the DLL. So DLL will be having all this information, and I'm not sure what this is about. Might be something. Yeah. So this is about the namespace and those things. Okay. So and DLL will be having a diamond symbol. Okay, diamond symbol. So that's the thing. So that's for today, and we will see in the next class some real programming. Like we will start creating some OOPS concepts we will look into. So next class we will start real OOPS concepts, and we will see the definitions, simple definitions to remember everything. So we will make them very simple, and from there we will go on. Okay, so that's it for today, and see you in the next class. If you have time, go through the today's class. I will be sharing the class material in a drive, and you can message me or you can message me separately, like your email ID. If I have, I will share you today's PPT, like whatever I presented in the class, that I will share, and I will try to host this video into YouTube and give you a link so you can refer it afterwards. But listening directly to the class will be helpful. I don't want you to something like using all the YouTube links and not listening to the classes. So sometimes like this doesn't get recorded also. So please listen to the class. Thank you.